Why did we select Dagster over an Airflow? So that was complicated. As you can see on the right, you have the support for custom resolution, but let's say now you want to add another ship processing. Thanks to using those, you can document pretty easily what is happening in your workflows. So what can go wrong? Welcome to today's Deep Talk. My name is Nikodem Tadrowski. I'm a machine learning engineer at DeepSense AI. And today I bring you a topic and an answer to the question, is Dagster the right choice for reliable AI ML data preparation pipelines? So today we will talk about main challenges that we have faced in data processing for our teams, overview of available frameworks, there are plethora of those, why we chose Dagster over Airflow, what Dagster gives you and what you build yourself, core concepts of the Dagster, and what works well and what could go wrong when you don't oversee your progress. There will be also some conclusions. So, why this topic? Our team recently has decided to start creating a single source of truth for all the uh, available data sources. So, why is this challenge? So, creating a single source of truth for transforming and processing your data is sometimes crucial, especially when you start seeing that in your company, many projects start to repeat the same preprocessings in each project. Though we also saw that there was some issues with data quality at the source, so from our vendors. We wanted to improve transparency for our stakeholders or people that wanted to use our tools to make sure that we can explain where did something come from. We also wanted to be able to choose freely any infrastructure type, as our team didn't have like resources for some of the AWS stuff or something like that. So what did we know already? What can our team handle? So we only wanted to use Python. We have used Cadro in the past. It wasn't a great choice for the this type of task that we want to handle. We want to be able to fully track the lineage of our data and its processing history. We wanted to prepare reports for the data owners in case of anomalies, and we wanted to make sure that the setup is simple and everyone can start contributing right away. So, what were the available options to choose from using Python? So, everyone knows that we have an Airflow, a mature, well-documented, widely adopted orchestrator, fits modern data workflows, and is recommended for most of use cases. There is also something like Prefect, which is very simple framework, and it strongly depends on the cloud infrastructures and offered limited native lineage tracking. Then there is Kedro, for which we have a lot of experience, but we know that it has some shortcomings, like it's difficult to scale, lacks orchestration, and historical data tracking for the runs that we've performed. There's also Flight, which is made to be used in cloud and leverage all your resources that you have available. But such setup would usually dictate a dedicated team to oversee the platforms, which was also not available for us. So there was also Dagster. So what did it offer? It's Python based. It's asset-centric. It's it has built-in data lineage and metadata tracking. It has strong typing and schema definition, built-in UI for running and overseeing the materializations, support for sensors and scheduling, enables multi-repository asset components, and it can run on a single machine or on a cloud infrastructure. Did we have any experience with the Dagster? No, but we wanted to give it a try. So why did we select Dagster over an Airflow? So the first thing was that, as I've mentioned previously, it's local first development makes it really easy to adapt to our existing infrastructures, our way of working, and we would be able to test many solutions or like test many different sources. For the Airflow, the setup is robust, but it's heavier and requires some infrastructure, although local development is also possible. Mm, The other thing is that Dagster was built from the beginning as an asset-centric model with explicit data dependencies and allowed for built-in observability of each asset. For the Airflow, it's more of a task-centric uh, framework, which was not something that we want to do. Uh, so, what does Dagster solve out of the box? Mm, It provides a lot of simple interfaces that can take you far, but also are easy to adapt for your own tasks. So, for example, we have an built-in I/O manager interface, which handles basic pickle data or the in-memory operations. What you need to do, you need to adapt your own I/O manager to support the Parquet, Excel, or other data types, or even databases in this case. There is a sensor interface which allows you to refresh your data based on external calls, and like provides an interval that queries the external APIs, or it can uh, put out an endpoint that can be called to start some process. There are asset checks, which is the validation option for your data and operations. There is a basic infrastructure. You simply run Dagster dev and everything, schedulers, logging databases, and workers are set up and you are ready to run your pipelines. Mm, What you can do as a developer is like also adapt the asset checks to uh, be able to use like in some well-known frameworks like Great Expectations or DBT. You can also adapt the infrastructure to like your own liking. That is like choosing Dask for your heavy computations or custom Kubernetes clusters to scale out the workers. There are also a lot of custom extensions and a lot of work is already done. You can like integrate DuckDB or like many more widely known frameworks for data engineers. So, what are the core Dagster concepts? As you can see, there is a lot of concepts that are building one whole structure. Uh, like we will start with some basic ones. So, the first one is asset. Asset is the representation of your data at the source. You can specify a lot of things to it. That is like the uh, type of storage that handles the data, like the operations that are performed on the data, and like metadata that is attached to this data. It can also be a part of a job that is running in scheduler on anything like that. Then you have your operations. Operations are just functions that perform some basic task and just take in some input and provide you with an output. The graphs are the next component that takes the multiple operations, their configuration, and creates a single unit that is replicable and can be easily configured uh, through the YAML files, for example. So what else do we have? We have components, and the component is a bigger structure that allows you to replicate your assets with simple configurations. Not only assets, as you can see on the graph on the right. There is also definitions, which holds all of the definitions of your concept components that you have built into your pipelines. Mm, okay, so that was complicated. So we wanted to start simple. Let's create a flow where each asset defines its own logic. That is, we will create three assets, one for extraction, one for transformation, and one for loading the data into some kind of storage. So how do you define an asset? You basically provide its I/O manager, so that is what file type mm, you will be handling, and that can be anything that you write. You can then reference an input asset, that is the previous stage that will be happening before entering this one. Uh, build there is a built-in context-aware logging, so that way you can log your information about the current asset and its dependencies. You can also attach already the metadata to an asset to provide some kind of feedback for the users. In between, you have any operations as you are, in this case, like working on the pandas data frame. Okay, so what do you get after materializing such asset? You have a run that provides you with all the logging that we have described. You can also see in the logging like any step that has happened, any next input and output, and what was its result. You can see the metadata definition in the form of JSON. So what also do you get? If you have made any mistake in your asset definition, then you can already see the error that comes from your asset. In this example, we have a clear uh, exception that says that we didn't define some function in our module. So what else do you get? You get a metadata that is in the form of like key value pairs. And if your data is of type int or like float or any numeric data, then you get automated conversion to plots and you can track over time how your data has changed. Mm, What you can else do is that you can also define your own plots with the Plotly library. Okay, great. But let's say now you want to add another ship processing. Previously it was Titanic, now we want to add another one. And here where the steps begin. It seems pointless to define like single asset per each operation as it creates unnecessary code duplication on a high scale, and you simply add the same asset every time when you extend your pipelines. But like the good things about ours, I mean the good things what we saw was that we like the UI and we see that everything that we see meets our expectations. So let's invest more time into learning. And that's how we come to the what works great and what can go wrong in the Dagster. So first thing that is great, those are components. What are components? Components, as I've said, is something that defines all the, I mean, replicable workflow. That is, if we want to create a Titanic, I mean the ship processing, then we can create a single component that defines some attributes that allow you to mm, parameterize this and replicate it very quickly. So, uh, like, what can go wrong with the components? You need a clear definition of those and treat those as abstraction, because if you start abstract too early, you usually end up with a YAML config nightmare, and you start to give like millions of parameters, and it's very complicated to read through the files. And it can also be substituted with a simple for loop with factory pattern, but that's not very elegant in this case. So how do you build a component? You define a component through a Dagster CLI with some scaffolding. Mm, You, after providing the comment, you just get an empty component that can be uh, further customized. By customization, we add usually the attributes and asset definitions. We define then the definition, that is the YAML file that will allow you to parameterize and replicate your component. And optionally, we can extend with custom parameters that can be referenced through Jinja templating in your own YAML. So as you can see on the right, you have the support for custom resolution of your objects so that you can still like keep some digts as Pydantic objects. You can have your additional scope, which is like a simple dig that can be referenced in your YAMLs. And you have your definition of replicable assets. And the only thing that changes between them is the asset name in this example. So how such definitions YAML look like? You get your type of uh, component, that is the ETL. You provide your attributes, that is your new asset names. You can reference, as said previously, your global variables, and you have your like standard attributes that we have provided. So that's it. That's a simple component. So what else? There are operations. Those are like the most basic unit of processing your data. And thanks to using those, you can document pretty easily what is happening in your workflows. Uh, Unfortunately, those require from you deep understanding of the code base when it comes to integrating. Because if you start to implement similar operations, you will see that you have a lot of code duplication, and that's not something that we want to have, like the same function but with the different name, which is not exactly correct. So how do you define such op? You simply annotate any of your existing functions with Dagster op decorator. Thanks to that, now you have fully typed function that is being checked for the data types of each input that is provided into it. Uh, there is one caveat with the operations currently. Each operation creates an artifact managed by IO Manager. By default, it's saving every single operations output as a pickle file in one of the directories. If you want to change that behavior, you will need to change the IO Manager, for example, to in memory. However, that would make it impossible to run a single operation on some data set, which will, as there is no preceding data existing on the machine, right? Mm, Then we have graphs. What are graphs? Graphs are just a set of operations with configuration. That is, you are building the graph on the right from operations, and you can reuse the operations with different alias to make sure that configuration does not get tangled up and we don't duplicate a lot of functionality. So what can go wrong? It's best to not change your operations, because if you do so, then you will need to change like configuration and your graph definition. And also the graph currently takes IO manager from last operation in sequence. And that can lead to confusion because you still can specify the output in the graph definition, but yet it still takes the IO manager from the last operation. So how does the graph look like? You have your definition of standard like uh, processing on the left, where you simply take the graph asset, you you specify the inputs, you specify the output, and in the body of your function, you have simply references to your operations with just the data frame in them. Uh, what else is happening? You can see the alias for the add category operation. Here you can add age group, for example, and then this can be referenced in your graph's configuration. For example, you can specify the columns for dropping, or you can specify the group age for the operation as it supports following parameters, which are then validated to be correct. Okay, so what did we learn today? Mm, the Dagster framework is not meant for quick setup. You can see that there are a lot of different concepts that do not translate very well into fast working. Basic configuration is enough to get you delivering results. We were able to, with the basic tools, to provide like some operational data that was easily replicable, and we were also able to later on substitute the configuration through like updating the interface, for example, in IO Manager. Mm, Typing system for operations makes those configs reliable. So this is also an issue in Kedro that it didn't validate our data. So we quickly had some like mistakenly made configs that thrown our like pipelines errors. The lineage makes process transparent and indicates issues early. You can see if any of the data is disappearing and you can track any parameter that you want. And also, like a final conclusion, is that Dagster is a great fit for maintaining your AI ML data, and we have been using it for the past couple of months without any issues. Thank you for today's deep talk and see you around.